Have you ever wondered how atoms form molecules and compounds? Well, it's all about chemical bonding, a fundamental concept that explains how atoms come together to form molecules and compounds. Imagine atoms as social beings. They bond to achieve stability, similar to how we form relationships to create a balanced life. They do this by filling their outer shell with electrons. There are three primary ways in which they achieve this: ionic bonding, covalent bonding, and metallic bonding. Ionic bonding is like an exchange program. One atom transfers one or more of its electrons to another atom. This transaction results in the formation of charged atoms, or ions. The giver becomes a positively charged cation, and the receiver a negatively charged anion. The bond between these ions is electrostatic, a magnetic-like attraction that holds the compound together. These ionic compounds are sturdy fellows with high melting and boiling points, and they conduct electricity when molten or dissolved. Covalent bonding, however, is more of a shared living situation. Atoms share pairs of electrons like roommates, splitting the rent. This type of bonding is common among non-metallic elements and compounds. Covalent bonds can be single, double, or triple, depending on the number of electron pairs shared. Covalent compounds are a versatile bunch. They have lower melting and boiling points than ionic compounds and can exist as solids, liquids, or gases at room temperature. Then we have metallic bonding, a hallmark of metals and their alloys. Picture a bustling city with people moving freely. In metallic bonds, the valence electrons are like these city dwellers, delocalized and free to move throughout the structure. This movement creates a sea of electrons that binds the metal atoms together. This unique bonding results in the malleability, ductility, and conductivity characteristic of metals. Beyond these primary types of bonding, there are also secondary forms like hydrogen bonding, van der Waals forces, and dipole-dipole interactions. These bonds may be secondary, but they play a crucial role in determining the physical and chemical properties of substances. Understanding these types of bonds is vital for several reasons. They influence a compound's solubility, reactivity, and physical state. They explain why metals are strong, why polymers are flexible, and why semiconductors can conduct electricity. They're also indispensable for fields like biochemistry, materials science, and pharmaceuticals. For example, understanding these bonds can help explain how enzymes interact with substrates, how proteins fold, and how drugs bind to receptors. So, to summarize, chemical bonds hold atoms together to form molecules and compounds. Ionic bonds involve the transfer of electrons, covalent bonds involve sharing, and metallic bonds involve a free flow of electrons. Beyond these, secondary bonds like hydrogen bonds and van der Waals forces also play a significant role in determining a substance's properties. By understanding these bonds, we can better comprehend the world around us, from the materials we use every day to the biological processes that keep us alive.